Today we are going to explain a simple audio player. Origin of the code is here. It is actually an audio video player, but let make reference to him. The original code I found on GitHub here. This is from Dmitry Ignatiev, ffmpeg tutorial, a well written working audio video player code. We have Windows headers, and if C++ is defined, we get C headers in external C block. Not to confuse with the STL main, we have STL main handles definition and STL headers. STL events defined here. This is audio packet maximum queue size. STL audio buffer size, this is the preferred size, and maximum frame size for quality video 192 kilobytes per second. So we will have our buffer bigger than this. To make sure our buffer will be bigger than this, we will add a bigger buffer. Output bitrate, output channels we want, and output sample format. We have packet queue definition here. In our previous video we talked about packet queue, and this is a simplified video state structure from ffmpeg. It's just for audio playing. Format context, codec context, resampling context, audio stream index, audio stream packet queue. We will talk about this in some other video. Audio buffer, buffer size and index, audio packet, audio frame. For the converted, after resampling data, we have converted data buffer. We will not be using these. Parser thread, let's check if it is used somewhere. Yes, it is not used anymore. And parser thread renderer, file name for input file, and quit flag. This is global video state variable pointer actually. Packet queue init, put and get functions. We explained them in the previous video. And we have decode audio frame function. Let's look at it very briefly. We get video states audio converted data buffer. There are two loops here. Important thing, we will use EB codec send packet and receive frame, not the depreciated audio decode frame function. Make sure we received every frame. We have a loop here, and make sure encoder is filled with enough packets. We have an outer while here. We get packet from our queue, send the packet to encoder with audio context, and if everything is okay, we receive frame. We calculate decoding data size, and we calculate the resampled data size, and we make the resampling conversion here. SVR context, output buffer, where we will have converted samples here, number of samples for the output, input, decoded. See, when we send the packet to encoder, encoder's audio frame data will be filled with decoded frames. So we will send this input to SVR context to make resampling, and this is the number of samples for the input, and we copy converted samples to our audio buffer to in order to send to STL callback, and here is the out size, and we release the packet for next use. Let's go for the main function. Audio stream, video stream we are not going to use. Let's check it again if it is used somewhere. Okay. Stream indexed, input file name, ST element definition, and video state. Here we make ffmpeg API registrations. Init STL audio and timer only, no video here. And we allocate memory for our video state. We copy the pointer to our global variable, so between callbacks other threads actually we can use this global video state, and we copy the file name to video states file name variable here. The default value for audio stream is -1. If we can't find any stream, we will return. Allocate format context, and this is a interrupt callback function. If something goes wrong with the I/O while reading the file, it will interrupt the decoding callback. Open the input file, get stream info, dump stream info, and for every stream dump information. And if it is an audio stream and there is no previously audio stream here, we take the first audio stream and make it our audio stream. If we find any audio stream, we go on we set the audio stream index to our video states audio stream index. If we find an audio stream, we open the stream component. Format context we get from video state, here the from parameter, and stream index another parameter. Codec context, codec parameters, and this is the STL audio wanted and audio specifications. We get these structs with these as default values. Okay. If there is some stream coming to this function, we get their codec parameters, find some decoder, allocate context, codec context, and copy codec parameters from format context. Here we get from format context to the codec context. Open the codec. If it is audio type, we get we set our codec context, predefined output channels and channel layout, and default values, and here we make our audio packet 0 as default value, allocate frame, allocate SVR context, and we set its options. Channel layout we get from decoding context. We make it same with the output. We want to use the same channel layout. It's mono or stereo. Sample rate we don't change it, and the data size, for input we use codec context. For output we use a non-planar floating format. I guess STL is not happy with planar formats, and we init SVR, and we define some wanted specs also. STL does not guarantee it, but if it is okay with STL, it make use of these specifications. 32-bit floating 4 byte, and decoding sample rate, decoding context channels, samples, how many samples, preferred size is 1024, and we see that our data will be 4 bytes each, so 1024 samples of 4 bytes, and per 2 channels, remember it was 2 channels stereo we want, and STL is going to demand 8 kilobytes of data at each callback. We use our video state as callback parameter, and we set our callback. Open STL, init packet queue, and make it wait until we start it. And we have the decoding thread here. Decoding thread is going to, if it is not quitted and if audio queue size is not maximum, is going to read file with format context and get some packet from file. If it is audio stream, we will put packets to the packet queue and release packet for next loop. Okay, we will have some STL timer to make refresh event here. At its callback we will refresh STL event for the next refresh. Decode interrupt callback. If something goes wrong, we will quit. Okay, let's go for the callback here. User data is, remember, our video state, and this is STL buffer. It will periodically demand data from us, so we will fill this buffer with data, and this is the data size it demands. If it demands any data, okay, if it demands any data, and if buffer index is bigger and equal to buffer size, the point here is we never decrease buffer size. When we get data from decoder, we will have a fixed buffer size, and as we send data to STL stream, we will forward our buffer index. So if it is the case that buffer index is already at least at buffer size, meaning our local buffer, video states, audio buffer is already emptied. Local buffer already empty. Here the author is not here also, already sent alt data, get more. We decode another frame, we get its size. If it has any size, we set our buffer size and we set buffer index to 0 at the beginning. Here here we get the calculate the length. We may have sent STL stream to STL stream some data, so buffer index may be forwarded. If it is 0, then our buff size will be our length here, but if it is forwarded, we get the length of the not set data, and the length in use available actually, if it is bigger than the length STL demands, we will make sure that it is as much as STL wants. You see, we make our local length to STL length here, and we copy data to STL stream here, audio buffer, and if index is not 0, it will go forward to as much as previously sent data, so we will send new data here, and this is the size, the length of data we are going to send. And if we send less data from STL length, we will increase in its length also, decrease its length, that we make another send in the loop, and we increase streams pointer as much as we send. We also forward our buffer index, local buffer, and we print data here. It's not complicated actually. We will see how it is work. Yes, we our thread here, decode thread, where we parse the file, read frames, and put into bucket queue. We schedule STL refresh as 40 milliseconds every 40 seconds. If it is not quitted, it's going to refresh, and STL callback will run demanding data from us. The cleanup part, okay. The basically we will pick STL will in every refresh, STL will demand data from us in this callback, and we will fill the STL buffer with data as much as it wants, and we make our controls here to make sure we send new data every time, and we put the data to the correct place by decreasing and increasing buffers, pointers actually. Okay, let's run wildlife default Windows file here to see what happens. You hear the sound here. We have buffer size, index changing instrument. Okay, let's see what has happened here. Okay, see here we have buffer size of 64 kilobytes. Our index we have sent remember is there demands data 8 kilobytes. Where is it? Okay, we have calculated here. It demands 8 kilobyte of data, and we fill the stream with 8 kilobyte and data, and the next loop we put another 8 kilobytes and we forward the buffer index. You see 8 kilobytes here, 16 kilobytes, then we have another 8 kilobytes, another, until we empty our local buffer and it gets new data from the decoder. This is that much left, and we send another 8 kilobyte and another 8 kilobyte. It is all played. Okay. In the next video we will talk about this code again, this piece of code again, talking in detail about this. For example, memory alignment. Why does auto uses memory alignment for the audio buffers? What's its use here? Also we will talk about resampling. What is resampling, why it is used, and what is bitrate, sample format, and layout. We will talk about these in detail. And we will change our sample rate to make some experiments what's going on and why we use planar here. And okay. And there is a piece of code here I have written but commented for this video, because we will see, we will try other videos and see what we have here, what is going on. Okay, that's it.